prove by mathematical induction that if n is a positive integer, then n raised to the power of 3 plus 2 multiplied by n is divisible by 3. So we all know that the first thing that we need to do is to test for n is equal to 1 is true by mathematical induction. So test for n is equal to 1 is true. That is the first thing. So this means anywhere I see n, from this expression, I am putting 1. So I have 1 cubed plus 2 multiplied by 1. And that is what? 1 plus 2, which is 3. 3 is what? Is divisible by 3. So you can go on and test for 2, 3, and so on. But because of this video, we are not doing that. So the next thing is assume n is equal to k is true. So this means anywhere I see n, I am putting k there. So I have k cubed plus 2k. And you can see we are assuming that this is true. So for it to be true, we have to equate it to be equal to 3 multiplied by any alphabet. Let's take m. So 3m implies that any number gotten from this expression, k cubed plus 2k, is divisible by 3. So from here, let's make k cubed the subject of the formula. So I have 3m minus 2k. So I'm calling this one equation 1 because I will need it later. So after this assumption, the next thing is that we have to prove that the next number after k, which is k plus 1, is true if n is equal to k is true. So prove that n is equal to k plus 1 is true. So this means anywhere I see n, I am putting what there? K plus 1. So I have k plus 1 cubed plus 2 into brackets k plus 1. So let's simplify k plus 1 cubed. That will be k cubed plus 3k squared plus 3k plus 1. Then simplify this. I have 2 multiplied by k, 2k, plus 2 multiplied by plus 1. That is plus 2. Anyway, I see k raised to power 3. I'm putting 3m minus 2k from equation 1. So I have 3m minus 2k. That is for k raised to power 3. So continue. I have 3k squared plus 3k plus 2k. Then 1 plus 2 plus 3. So from here I have minus 2k plus 2k. So minus 2k cancel plus 2k. So I am left with 3m plus 3k squared plus 3k plus 3. We can see that all this one, they are multiples of 3. That is, they are divisible by 3. So let's factorize 3 out. So I have 3 into brackets m plus k squared plus k plus 1. So this means that it is divisible by 3. So since this happened, we can say that when n is equal to k is true, anytime n is equal to k is true, then n is equal to k plus 1 is also true. So for this particular expression, 2n, this is divisible by 3 for any positive integer n. You can see this is very simple. You just have to do it in the sense that it will later be divisible by 3. So please go through it. If you have any question for me, please let me know.